In this video, we'll discuss limit at infinity and also horizontal asymptote. Right? Let's see a motivating example here. Our example here is given a rational function. Recall that rational function is basically the quotient of two polynomials. So we have two very easy polynomials, x squared plus 1 and x squared minus 1, right? We have a polynomial here. You can see that the domain of this function is all real numbers because x squared plus 1 can never be 0, right? So if you want to understand how does this function behave, right? We want to understand the graphs and things, right? One thing we want to know is what happens if x is getting larger and larger and larger, right? So let's try to write down a few numbers to see what happens. So starting from x here and f of x, right? And starting from 1, if you're starting from 1, you can calculate function value at 1 will be 0. And you plug in 10, you get 0 0.980198. And plug in 100, you get 0 0.999800. If you plug in 1000, you get 0 0.99998. You can see that as x getting larger and larger, you can go all the way to as large as you want, right? We call that x value here goes to infinity, right? So y value is going to a fixed place, right? You can see that this clearly goes to 1, right? So if this happens, we say that as x goes to infinity, our function value f of x goes to 1, right? And do a similar discussion here. You can see that also as x goes to negative infinity, f of x also goes to 1 because this function, the even function. So what happens when x getting larger and larger go to infinity, same thing happens as x getting larger and larger, negative, it goes to negative infinity, right? So if this happens, we call this limit is a limit at infinity, right? This deserve official definition. Let me write down the definition here. So definition here is called the limit at infinities. There are two kinds of infinities. One is going to the right side, and the other one goes to the left side, right? Positive infinity and negative infinity. So this is either positive infinity or negative infinity. Their definition are very, very similar, right? One is x getting larger and larger without upper bound. The other one is getting larger and larger negatively without lower bound. So the notation is clear, right? We should be the limit of f of x as x goes to negative infinity, right? This is equal to a finite number, we call that L. And if what happens, the values of f of x can be made arbitrarily close to L, right? By requiring x sufficiently large, right? because x is just infinity, just a trend, right? It can never be reached. So we don't need to say that x we cannot doesn't equal to infinity, right? So lots of similar definitions. So similar definitions. You can define what's the meaning of as x goes to negative infinity, f of x equal to L, right? Or you can define what's the meaning of x goes to positive infinity, f of x equal to positive infinity or negative infinity, right? Or you can define as x goes to negative infinity, the function value is going to positive infinity or negative infinity, right? Just place with our definition here, right? And do some corresponding modification, you can get this 5 more definitions, right? So if the function value getting closer and closer to a number, right? Which means, let me try to sketch what happens here, right? So the function value in this example, as x getting larger and larger without upper bound, the function value is getting closer and closer to the horizontal line, which is y equal to 1. So if you call this is 1 here, so this is y equal to 1, right? So what happens on the right side is something like this, right? So that means y equal to 1 is a horizontal asymptote because our curve is getting closer and closer to that number, which is y equal to 1, that horizontal line, right? So if this happens, we get some good property of the graph, right? Let's write a definition here. Definition is y equal to L. So L has to be a finite number, right? So let me put it here. So L here is a finite number, finite number. When you have a finite limit at infinity, you got a horizontal asymptote, right? So is a horizontal asymptote of y equal to f of x if either what if what happens is either you have the limit at infinity is L, or the limit at negative infinity is L, right? So that's basically our definition for the horizontal asymptote, f of x equal to L, or the limit as x goes to negative infinity, f of x equal to L, right? So that's basically our definition of the limit at infinity is either positive infinity or negative infinity. This limit could be a finite number or could be a positive infinity or negative infinity. But if you have a finite number as a limit at the infinity, one of the infinities, then this y equal to this number is called a horizontal asymptote.